The X2D is the brand new printer from Bambu, and it's what you might expect if you merge the affordability of the P2S and the advanced features of the H2D. And today we will be looking at all of those features, including some that only this printer has. We'll be testing the printer on some of my own designs as well as a few from MakerWorld, and then we'll go over any problems I ran into during my testing, and then I can give you my overall thoughts on this printer too. So let's get into it. At first, it looks a lot like the P2S, and there are a lot of similarities on the outside, but there are a few differences. Dual viewing windows, one of these at each side, which does let in more light, but it also allows you to see the back of your print while it's printing to make sure that everything's going properly. That's not something you would have been able to see very easily before from the front, either through the door or with the camera either. Now at the back, we can see we have a dual individual filament buffer, so a dedicated filament buffer for each line that comes in. And there's also some other differences at the back that we'll talk about in a minute. When we look to the inside, there are actually a lot of changes. So starting with the most obvious, the dual hot end setup, this printer actually has an advantage over the H2D in that it uses the motion of the printer to change between the hot ends, and the change is really fast, as you can see with this real-time footage. This is really smart because now there is no need for a small switching motor. It's going to be purely mechanical, and along with that, the X2D hot end spacing is closer together, so it maximizes the printable space on the build plate for both of the hot ends. The left hot end is the main one and the right one is the auxiliary, and you can see in Bambu Studio that the left hot end has access to the entire print volume, 256 by 256 by 260 now, with the auxiliary hot end being able to reach 235.5 by 256 by 256. And the hot ends are the same quick swappable with the hardened steel tips used on all Bambu's new printers, so they can be shared and they do work really well. There is also a nozzle blocker to prevent oozing, and the printer has dual hot end cooling fans, one for each of those hot ends. So when I unboxed the X2D, there were some pieces inside the chamber that I didn't completely understand, and one was the horizontal finger coming out from the back, and the other one was a steel spring-loaded finger at the center top, also at the back. So I watched the printer while it was working to find out what they were actually for. The horizontal finger is actually what's used for swapping the hot ends, and it interacts with this hidden system at the back. So we have a fast hot end swap without the need for an extra motor. But the finger at the top is actually even cooler. As you might notice, there is no filament cutter on both the left or the right sides. So instead, Bambu has found a way to move that to the back, and you wouldn't even know that it's there. The finger presses these little tiny buttons. It's really slick, but there is actually a side benefit to that too. The other printers have the finger that flicks out as the head passes by, and then the cuts can be made. That flick is actually fairly loud. This printer does not have that, and the filament cuts are now quiet. This printer has a side-mounted camera to the right-hand side of the head, and it works natively with a small calibration board on the heat bed, but I believe there will also be a vision encoder option available, just like we have for the H2D and the H2C. The monitoring camera is mounted to the top left front corner, and it also has a little flap that you can close if you're concerned about privacy. This printer has a max hot end temperature of 300 degrees Celsius, which is high enough for most filaments, and the max bed temperature is now 120 degrees Celsius with a max chamber temperature of 65 degrees Celsius, so it can handle ABS, ASA, nylon, and even up to PET. One of the big benefits of a Bambu printer is that they calibrate filament automatically, and there is a continuous monitoring and also adjustments during the print for the best results. On this printer, the main hot end has that calibration capability, but the auxiliary hot end does not. So it uses previously calibrated values, or in some cases a default value if there are no other values to reference. If you're using Bambu filaments with a Bambu printer, you should see really good results regardless of what you're doing. But if you're not, it's possible the auxiliary hot end results will vary a little bit. So this is the auxiliary extruder. When I first took a look at this printer, I wasn't really sure what this was here for, but it is very important for the function of this printer, and I'll show you why that is. So on this side, the main hot end side, we have that side being driven by the permanent magnet synchronous motor, so it's a direct drive setup. The auxiliary side, you can see that we don't have any extruder gears on that side. So that side is being fed by the auxiliary extruder at the back there. So the auxiliary extruder is actually a Bowden setup. So what that actually means is that on the auxiliary side, there's a little less fine control during extrusions and retractions than we have on this side over here. Now, I haven't actually noticed much of a difference in the prints that I've made, but maybe if you're doing extremely fine details, you might notice some sort of a difference. At the back of the bed, there is also a nozzle offset calibration panel that makes sure that over time, the position of each nozzle tip in relationship to each other are correct for the best results. The X2D also has 2 auxiliary fans for cooling, which means better cooling for lower temperature filaments. And when it's in heating mode, it also filters the air through the multi-stage carbon and HEPA filter system, which is on the right side, similar to what you'd see with a bento box. When the high temperature print is finished, under print options, you can actually select what you'd like it to do. So if you want your chamber air to be filtered, or if you'd want it to exhaust that chamber air outside. At the back of the printer, we now have this externally mounted exhaust system. So for lower temperature filaments, it is always on, which makes sense because the auxiliary fans pull cool air now from the outside of the printer, and the pressure would tend to build and the fans would cease to work properly unless there was somewhere for that air to go. For the high temperature filaments, the auxiliary fans instead work together to filter that interior cabin air. And it seems to work pretty well because I was working beside the printer while I was printing with ASA, and there was very little odor, and my air quality monitor was showing pretty good air quality as well, with only rising CO2 levels because I was working really close by. Now, I was able to run the dry cycle and print at the same time using the AMS high temperature on this printer. I'm not sure if that is enabled now thanks to a firmware update or just something that I hadn't tried in the past, but it's nice to have that option if you're desperate to print a spool of filament that has absorbed some moisture and you just can't wait. Okay. I wanted to check the bed heating against several other printers that I've tested in the past to see how fast it heats and how even the bed heating is. So I set up my thermal camera, set the bed temperature to 100 degrees Celsius, and I waited. It took less than 2 minutes to reach that 100 degrees, and then, like my previous tests, I let it soak for a few minutes as well. I was expecting identical results to the P2S, but it turns out that the X2D has slightly more even bed temperature and slightly closer to the set temperature as well. The lower the values you see here, the better, and you can see that the X2D has taken first place against all of the printers that I've tested. So last summer, I was stung multiple times on my ankle and then once on my hand by wasps, and then I had an allergic reaction to those stings. So I decided to print this realistic looking wasp nest, which is a deterrent to see if it would help at all to keep them away. It is the most lifelike one that I've been able to find. This one was designed by Nav Y Terra. I don't know how to pronounce that, and it's going to be linked below. I printed it with walnut wood PLA filament, which does seem to stand up better to heat than just standard PLA. Now, I probably could use a little bit of dry brushing to make it look a bit more realistic looking, but I'm not a wasp. I don't know what they see, so I'm not even sure if it's needed. The X2D works really well with models like this because I've used support interface filament on the auxiliary hot end for that easy support material. And with that filament, I also like to make the interface completely solid so I get a really nice finish there too. This is a cord wrap that I designed for the iconic KitchenAid mixer, and it's similar to the last one in that it requires support material when it's being printed. I usually avoid designing and printing with supports, but with this printer I don't really need to worry about supports anymore, so again, it does show some of the benefits of the added hot end here. This is one I printed with white only because it's going to be installed on a friend's mixer and their mixer is white. Here's a purple version so you can see some of the detail a little bit better. I like to use a very, very light fuzzy skin, and where there are overhangs, I use adaptive layer heights to get the best results. I wanted to move to some testing for some higher temperature materials, and this printer can be exhausted outside or into an air purifier with an adapter. So I printed this adapter in ASA. The chamber temperature went right up to 65 degrees Celsius, and again, I turned on the lightest fuzzy skin possible on the outside contour only. And here you can see we have excellent results. And best of all, it actually does work. It doesn't really even look like it's 3D printed with that 0.1 by 0.1 fuzzy skin, and it also happens to slow down the outside with that fuzz, and that's a side benefit because we don't have the auxiliary fans blowing cool air on the parts because these are printed in a heated chamber. One of my most popular designs ever was the Anaconda filter, and I wanted to test printing it with polycarbonate so it holds up outside all year long. This one is normally printed with PETG, and it's really tough to print, but with polycarbonate we have a 60 degrees Celsius chamber and 100 degrees Celsius bed, and only very little part cooling and no auxiliary fan cooling. So the results here are pretty good. There was a little bit of difficulty on the overhangs, and if I were to print this again, I think I would just slow it down by about 10%, and I think that probably would have made a bit of a difference. Overall, it still looks really good, and most importantly, it still will function properly when I insert that fine stainless steel mesh on the inside. And I'm not just printing these for a test, these are actually real functional parts that will be used. I've also printed a few parts for our upcoming fully 3D printable Kickstarter just to see how they look with dual colors. So these are printed from Pruning PLA in Galaxy Black on the main hot end and Bambu Sparkle Gray PLA on the auxiliary. So normally these are printed in just a single color for the quickest print, but with two colors, if I were to print these on a printer like the X1C, they would require 128 color changes. On this printer, that's minimized to a total of 2 color changes, and that's just for the initial loading of the filament, and that's it. These gaming accessories turned out great, and if you're curious what these pieces do and what the other parts of the set are, I'll make sure to link below to the Kickstarter page, and you'll find it under Extruder under the company name Gridmax. Lastly, I'm working on a design for air pruning pots, and I wanted to print these on the X2D and try them out. In a normal pot, the roots reach down to the bottom, and then they start to encircle the bottom where it's most moist. They'll continue to go around and around the pot, and if it's a tree, for example, over time, those roots will continue to grow, and then it'll cause the tree to suffer as they grow right into each other. The idea with this design is the roots grow until they're exposed to air, and that causes the roots to stop, and they'll fork off in multiple directions from there. These types of prints are extremely difficult to get good results on because we have so many starts and stops. And this is where pressure advance or dynamic flow calibration really comes into play to help produce the best quality result. Now, what I found in this case was that they're pretty good. And again, I do use top-down lighting in my videos. I try and show the worst case scenario, either using gray or I use purple as well. They show defects a lot more easily than other colors of filament. I used the P2S and made a VFA test, and the results were actually really good even with a 2mm belt tooth spacing. I compared that to the X2D with the 1.5mm belt tooth spacing, but I wasn't able to get the spiralize to work correctly on the X2D. So you can see clearly here where it changed in its height. So the test really isn't a great comparison, but if we only look at the VFAs, we can see that there is a slight difference between the X2D having a little bit smaller visible range than the P2S. When the X1C was originally released, it was around $1,200 US or so for the printer alone, and the AMS combo was about $1,450 US. The interesting thing is that the X2D, even though it has so much more, is not more expensive. It isn't even the same price. For the printer alone, it's $649 US, and for the AMS combo, it's $899 US. So that definitely puts it into a much more affordable range for anyone printing for fun or for a small business, and definitely a great price for anyone using it for commercial use. So I've run nearly 200 hours of prints to test this printer out, and during that time I've had two minor problems. One was that the X2D did not recognize my original Bambu SuperTac build plate. It actually warns me in advance that there might be a problem when using it. And it was right, I did have some problems when printing with it. So I've gone ahead and I've ordered the brand new SuperTac Pro, which works supposedly on every single printer at that size. So it'll be good to test that one out too. And the other issue I ran into was that one of the slots for the MS2 Pro was not feeding filament incorrectly. So I replaced that one piece of PTFE tubing, which can be done from the top really easily, and that fixed the problem. When I thought about it a bit more, it's likely that the tube just wasn't seated in completely into the connector at the end towards the second stage feeder. Overall, this is an excellent, heavily upgraded version of one of the best printers of all time, and one extra color or one extra material with very little waste works great for me. And of course, it also works well with more colors too, but there will be more waste. Now, with every printer that I test, I actually collect every piece of printer poop and every piece of waste. And so far, after a couple of 100 hours, this is what I have. And most of this is from calibration cycles because I keep calibration turned on for every single print. Now, I've mainly focused on printing functional parts, so you need to decide for yourself if this printer makes sense for you. There are also prime towers, and they seem excessively large for some reason right now, just like what we had with the H2C when they were being tested too. So I've been shrinking them down manually, and they seem to be still performing really well. As companies grow and become a brand name, quality can start to suffer as they rely more on their name. But in Bambu's case, I don't see any of that happening. In fact, they continue to innovate and simplify wherever possible, which is a benefit to us because we have less complexity, less parts to wear down, less parts to break. And that's one of the things that I like most about Bambu printers. They just work and work for a very long time too. And because of that, they also retain their value really well. And if you're a designer, one of the biggest advantages I found with Bambu is the ability to design and post on MakerWorld and for those designs to earn you points. For me, I have not spent any money to buy filament or parts in a very long time. I use my points, and since the points also work towards shipping, it only costs me the time to post my designs. So there are actually other benefits to a Bambu printer which aren't always talked about. If you decide this printer is right for you, I will have a link down there below in the video description, and that link does help to support this channel to keep making content like this. So thank you in advance if you do choose to use it. Thanks to Bambu for sending this printer for me to test out. It's going to get a lot of use in my shop. And thank you to each of my patrons for supporting this channel, and thank you for watching. I hope to see you on the next one. Time the position of each nozzle.